one good day in algebra, we'll be covering how to graph a linear inequality on the coordinate plane. We spent the last unit and change graphing equations, solving equations. We dabbled in inequalities a little bit. And who can remind us the difference between, the key difference between an equation and an inequality? Solving an equation, solving an inequality, how are they different? Yes, Blake? An equation does have a variable that we're solving for, right? You know, we solved equations with variables on both sides, and we solved equations where we had to distribute and combine like terms. So equations can definitely have variables. Peter?
Equations don't have like greater than or less than signs?
Yeah, the equations don't have these four symbols because why? When we have the equation, and I'll do it in the margins here, you don't have to write this down if you don't want to, but if we have the equation x plus 9 equals 11, and we solve this to be x equals 2, versus x plus 9 is less than 11, and we solve this to be x is less than 2, what's the difference between these two solutions? Which leads us to the difference between an equation and an inequality. Right, x is 2. That's it. Okay, 2 is the only value that's going to make that equation true. Whereas in an inequality, if you remember, the last step here is to graph this on a number line because, well, if x can be less than 2, that's a lot of different values x could be, right? X could be 1. 1 plus 9 is less than 11. X could be 0. 0 plus 9 is less than 11. Okay? So the difference between an equation and an inequality is that an equation gives you one thing, one answer. Okay? Whereas an inequality gives you a whole range, which is why we have to graph it. Now, you might recognize this graph, this horizontal line, as kind of the x-axis of a coordinate plane. Right? And the reason why we only need the x-axis or one axis is because we only have one variable. When we start talking about linear inequalities, and here's an example here, y is less than 3x minus 4, because we now have that y variable as well, we have to add a second axis to graph this, and thus we have our coordinate plane. Okay? We just graphed equations in slope-intercept form, y equals mx plus b. Recognize that this inequality here, y is less than 3x minus 4, is in slope-intercept form. It's not y equals mx plus b, but it's y is less than, greater than, one of the inequality symbols, mx plus b. So just by looking at this inequality, tell me how we're going to graph it on the coordinate plane. Yeah, Joey. Start with the y-intercept, which is? Negative 4. And then? Slope is 3. Up 3 over 1. Exactly. Same exact process as an equation in slope-intercept form. We have the y-intercept and we have the slope. So let me scroll down here so we can do it together. Okay. Using this inequality as an example, we're going to plot our first point down at negative 4 on the y-axis. Okay. And then we're going to use our slope to go up 3 over 1. And don't connect the points yet. If you were working ahead and you already don't go too far ahead here, because inequalities do have some quirks to them. Okay, but first plotting that y-intercept point at 0, negative 4, then using our slope 3 over 1, up 3 over 1, we get those two ordered pairs plotted. Okay, so far, graphing this is just like an equation. Similar to solving an inequality is just like solving an equation. Opposite operations, get the variable by itself, okay? But now is where we need to look at this symbol, that less than symbol. And I ask you here, will the line of the graph be dotted or solid? Dotted or solid? Remember when we solved inequalities earlier, we had the less than, greater than, and the less than or equal to, greater than or equal to? What type of circle did we have for less than and greater than? Blake? Open circle. Why was that, Blake? Do you remember why? but it couldn't be that actual value, right? It couldn't be that target number. Earlier, when we had x plus 9 is less than 11, we had x is less than 2. It couldn't actually be 2 because 2 plus 9 equals 11. It's not less than 11. And then when we had the or equal to part, it was that closed circle, right? Telling us that the solutions could be that actual number. It's a similar thing here, only instead of open circles and closed circles, we use dotted lines and solid lines, okay? So for the less than symbol, which correlates to the open circle, on the graph here, it's going to correlate to a dotted line. And if you thought I had a hard time making solid lines, I'm even worse making straight dotted lines. So we're just going to go nice and slow. Whoop, hit the points, keep going up, and there we have it. Okay? And what that dotted line means is that any ordered pair that's on the line doesn't actually work in the inequality. Just like before, when we had x is less than 2, 2 doesn't actually work in the inequality, but everything less than that does. And that's why we had our open circle and going to the left here. Okay. If I use my slope again, you can see how inaccurate I was here. This order, that's just horrible. How embarrassing that all my years of schooling and teaching, I still can't make a straight line. Anyway, using slope, going up 3 over 1 a second time, I get that third ordered pair, which is 2, 2. If I plug in 2, 2 into my inequality, so instead of y is less than 3x minus 4, I get 2 is less than 3 times 2 minus 4. Right? Or 2 is less than 6 minus 4. That simplifies down to me 2 is less than 2. Is that true? Okay. What I did here was I took my original inequality, y is less than 3x minus 4, and I plugged in an ordered pair that's on my line, 2, 2. So 2 for x and 2 for y. I simplified it. 3 times 2 is 6, minus 4, the right side of this equals 2, and I get 2 is less than 2. True or false? False, right? So the ordered pair that's on the line doesn't actually work in the inequality, which is why it needs to be dotted. Okay? And the reason why is because it's got that less than symbol, and the ordered pairs on the line don't actually work. The second, so that's the first quirk with graphing inequalities. Is the line dotted or is it solid? Okay. The second quirk, this one here says which side of the graph includes solutions. Just like how when we had to kind of shade or give an arrow on one side of our inequality graph to show which side of 2 the x values worked on, we're going to do the same thing here. And if you think back to last objective, what did I have you do? I had you take an ordered pair and plug it into an inequality and test and see if it worked. The reason why is because that's what we need to do here. So give me an ordered pair anywhere on the coordinate plane that's not on the line. Blake. 0, 0. Okay? 0, 0 is not on the line, and we're going to use that point, plug it into our original inequality to see if it works, which is the objective we did, CO31, right? So we've got y is less than 3x minus 4. We're plugging in 0, 0. So we have 0 for y, 0 for x. When you get 0 is less than 3 times 0 minus 4. What is the right side of that simplified to be? 3 times 0 minus 4. Yeah. Negative 4. Is 0 less than negative 4? No. So does 0, 0 work in our inequality? No. And because 0, 0 doesn't work, neither will any other ordered pair on that side of the line. Okay, but we're think about this line as like a top and a bottom, or a left and a right. 0, 0 was on that kind of top side of the line we made. It doesn't work, so neither will any other ordered pair that's on that side of the line as 0, 0. And don't think of the lines as the x and the y axis. Think of the line that we graphed. So just to prove ourselves right here, give me an ordered pair that's on the other side of the line that we graphed. In theory, hopefully works here, otherwise we're in some trouble. Peter? 5, 5. Okay? 5, 5 is on the other side of the line as 0, 0, so in theory, this should work. Let's test it. So we're going to plug in 5 for y and 5 for x. We get 5 is less than 3 times 5 minus 4. What does that right side simplify to be? 11. Is 5 less than 11? Last time I checked, it was. Okay. So because that red ordered pair works, and it's on kind of that bottom right side of the line that we graphed, every other ordered pair on that side of the line is also going to work. So here's where it gets fun. The final solution to this graph is the line that's dotted, and then we shade the entire side of the line that represents where our solutions are. It's almost like it's art class. Questions on any of this? It seems like it's kind of a lot. You know, it took us about 7 minutes to go over this one example here, but it's really the same as an equation until you get to, is the line dotted or solid, which again, you're just looking at the inequality symbol for that. Would it be open circle or closed circle, right? And then you're testing an ordered pair to see which side of the line has the solutions, which side of the line you shade. All right? We're going to skip this table here for now and go down to the section where you've got 3 to practice. And let's do the middle one. We'll save fractions for just a little bit here. Y is less than or equal to negative 3x plus 2. Right off the bat, is this going to be a dotted line or a solid line? Solid, because it has that or equal to part, right? Okay. So we're going to graph this the same way we would as if it were an equation. Our y-intercept is positive 2, as the equation gives us there. And our slope is negative 3, which means we're going down 3, right 1. Okay? And because it's a solid line, we can just go ahead and connect it as we would. Whoops. And the fact that it's a solid line means what? As far as the ordered pairs that are on the line. Will those ordered pairs work in the inequality, or will they not work? They will work. Okay? They will work. That's why it's solid, just like that closed circle before. Someone give me an ordered pair that's not on the line. Caleb. 2, 4. Okay? And what we're doing here is we're testing this ordered pair. If it works, that means that all the other ordered pairs on that side of the line will also work, and that's the side that we're going to shade. If it doesn't work, that means everything on the other side of the line works, and that's the side that we'll shade. So with 2, 4, we've got our inequality here. We're going to plug in 4 for y, 2 for x. I should do that so we have some more space to write below it here. 4 for y, 2 for x. And again, that came from the ordered pair that we're testing here, 2, 4. Right. What does that right side simplify to be? Negative 3 times 2 plus 2. Will? Negative 4. Is 4 less than or equal to negative 4? It is not. So that ordered pair that we picked doesn't work, which means nothing else on that side of the line is going to work. So we're shading the other side. I always feel bad because it's such a waste of this smartboard ink to shade that large of a section. But such a waste. Okay, let's go to one of our other ones that are fractionized here. Y is greater than 2/3 x plus 1. Go ahead and plot your points. If you feel comfortable drawing the line, if you know whether it'll be dotted or solid, you can go ahead and connect them also. And if you're really feeling bold and want to pick an ordered pair to test, you can even do that as well. Otherwise, we'll go through everything together. But y is greater than 2/3 x plus 1. Oh, not too bad. Okay. Your line should look like mine, where your y-intercept at positive 1. I went up 2 and right 3 to get my second point based on my slope. And I know it's going to be a dotted line because it's the greater than symbol. It's as if it's an open circle there, right? All right. Give me an ordered pair to test and make it a smart ordered pair. Michael?
So smart as in like easy or smart as in like harder?
Smart as in easy.
0, 0.
I should say make it an efficient ordered pair. 0, 0 is always a great one to test because whenever you have a fraction, 0, 0, it just eliminates it, right? Because you're multiplying that fraction by 0, and so it's gone. Okay, so 0, 0 is a great point to test here. What would if the line's kind of close to 0, 0, or if it passes through 0, 0, then you couldn't use that point. What would another smart, efficient, easy point be to use here? Blake?
1, 1.
I'll argue against 1, 1 because if I plug in 1, 1, that 1 value for x, I get 2/3 times 1. How fun is it to work with fractions? Not very much fun. Okay. Joel? So give me an ordered pair. 3, negative 3. The reason why 3, negative 3 would be an efficient ordered pair to use is because that x value 3, what's going to happen if I multiply my fraction by 3? It cancels out, right? This only goes out to 5, but if you wanted to use like 6, 1, which would be right about here, 6 would also be a smart x value to use because what's going to happen if I multiply that fraction by 6? It gets rid of it, okay? Because what I'm multiplying by is a multiple of my denominator. If my fraction was, over here, negative 5 halves, I'd pick an even number to use, like 2 or 4 or 6. Anything even is going to cancel that out, right? But 0, 0 is a great one just because it really simplifies things well. So plugging in 0, 0, we've got y is greater than 2/3 x plus 1, or 0 is greater than 2/3 times 0 plus 1. This 2/3 times 0 cancels out because it equals 0. Is 0 greater than 1? No. So am I shading the side with 0, 0? No. I'm shading the other side. Okay. Last one here. Y is greater than or equal to negative 5 halves x plus 7. This one goes off the coordinate plane. I apologize for that. So 7 is right about here on the y-axis. Probably a little bit lower than that, but oh well. And then our slope, down 5, right 2, since it's negative 5 halves. So down 5 from 7 will put us at 2. Right 2 puts us here. And is this going to be dotted or solid? Solid. Greater than or equal to. Okay. What's an ordered pair we can test here? Blake, why not 0, 0? Why not? Okay. Testing 0, 0 means we're going to plug in 0 for y, 0 for x. The fun part about 0, 0 is that negative 5 halves times x, all cancels out. And we're left with 0 is greater than or equal to 7. True or false? False. I heard someone say true, false. 0 is not greater than or equal to 7. Therefore, we're shading the other side of the line. Okay. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this? Peter?
What are we going to do with that table?
Well, we're going to fill it out tomorrow. If you haven't picked it up, how I like to roll is I teach you how to do it the less efficient way, have you discover the more efficient way, and then I show you the more efficient way. Self-discovery is the best way to learn and remember something. So I want to give you that opportunity today. This is a key point, so it's pretty important. You can put it on a help sheet. We're not going to go over it just yet. Look for patterns. Look for connections. Okay. Your homework for tomorrow is the second page of CO32. You've got 9 opportunities to impress me with your graphing inequality skills. And so, right, 9, or I give you 12? On the second page, there are 9 opportunities here for you to graph a linear inequality. The first 3 are pretty straightforward. I don't think there's anything that jumps out in that top row that's like, ooh, I'm not quite sure how to do that. Maybe the third one, where we have y is less than or equal to x plus 3. What's our slope in that third one? Y is less than or equal to x plus 3. Do you know? Good. It's not written. It's that hidden 1, but 1x, if x is just by itself, it's 1 over 1. It's a coefficient of 1. Okay. The second row, maybe look at that one. That first one might jump out at you. What's the y-intercept of y is greater than 2x? 0, right? Because we write plus 0 doesn't change the value, so we just don't write it because mathematicians are lazy. But y is greater than 2x plus 0. So for that one, can you test 0, 0? No, because it's on the line, right? It passes through the origin, so you have to pick a different point. That's okay. You'll be fine. All right.
Well, that one's backwards. I don't like that.
Row 3, the inequalities are given to you in standard form. So it's kind of a blast from the past, looking at PO24, where we learned how to convert from slope-intercept to standard form. Your process is the same here. Pick one that you want to do together. First, second, or third. Morgan, is that a hand up? Yeah. The third one, the last one, of course. Negative 5x plus 3y is less than negative 3. I'm going to rewrite that down below, give myself a little more space here. So we have negative 5x plus 3y is less than negative 3. This is in standard form. Both x and y are on the same side of our inequality. So to put it in the slope-intercept form, we have to move our x term over using opposite operations. So we're going to add 5x to both sides. That leaves us with 3y on the left, because these cancel out. And then 5x minus 3 on the right because we can't combine those. One has an x and one does not. Okay, so you have to keep them separate. What's our second step? Yeah. Divide everything by 3. Good. And this is where I had fun drawing like little, look like hearts on the videos. Yeah, okay. Because we love math. Okay. How much did you mock me when I was doing that on the videos and wasn't here to? Was the mocking pretty hardcore or no? No, okay. So the 3's cancel out, and we have y is less than 5 divided by 3 doesn't work out, but do we care? No, because that's just going to be our slope. Slope is a fraction. So don't go to your calculator to write the decimal value of 5 divided by 3. Just leave it as 5/3. And then -3 divided by 3, pay attention to signs there, is a -1. So there's your inequality in slope-intercept form. Y is less than 5/3 x minus 1. That's what you'll be graphing on the corner plane. Alrighty? So, just like equations, except is the line dotted or solid? And then you need to shade one of the sides. Okay? When you do this second one in the bottom row here, be careful. Be careful. That's all I want to say. Be careful. Yeah. All right, you've got about 5 minutes to start working now. This is going to be due tomorrow. We will go over it together. No Google quiz today because you got the work in your binder. So that, folks, is how you math.
Don't forget to like and subscribe.
And when you watch a video from Google Classroom, don't forget to click the link.